Welcome back, guys. Today we'll keep going on, and today I'd like to talk to you about the analog signals. Until now, we work on the digital signals, guys. When we have our own Arduino here, as you see, we have got analog inputs, guys. We are going to use analog inputs anymore in that project specifically. But till now, we talk about and we work on a digital signal, and we know the digital signals is 0 and 5 voltage, high or low, 0 or 1. But today I'm going to talk to you about the analog signal, and analog signal is the value between the 0 and 5 voltage because it is really live. Sometimes you might need to read a value from outside as an analog signal, like the 4 voltage, 3.5, anything else between 0 and 5, and then you are going to process your program according to your analog signal. But how we are going to exactly do that? But you should know, guys, there is analog to digital converter. It means you are going to read analog from outside, from a sensor or port, and your Arduino is going to convert it to the digital signal, and we are going to process it. But the point is, you should know, guys, there is no digital to analog signal. It means we are never going to be able to have an analog signal from the outside of Arduino, unfortunately. But we have a PWM module that I'm going to talk to you in the next. I plan to talk to you in the next video. We can act like that. We have an analog signal by the PWM module, but till that video you should know that there is no analog signal from outside. Actually, even if we talk about the PWM module, it is not going to be analog signal. This is the kind of trick that we are going to implement on Arduino. This is the first thing, guys, you should know. Never forget, no analog output in Arduino. But what does it mean exactly, analog input? Here we go. I have got my own analog to digital converter electrical schematic diagram here. We read the voltage from input. It might be here the 60 millivolt, it might be 100 millivolt, 4 volt, 3 volt, anything else, and it is converted into the digital value here. And for example, here in that counter we have got 8-bit counter, but in Arduino, when we talk about the Arduino, we can read the analog value as a 10-bit, and we already talked the addresses. In this case, we have a 10-bit analog addresses. What does it mean? Let's have a simple math and try to understand the idea of analog input. Imagine that we have 10 digits, isn't it, in one address, in the one line, 0 0 0 till 10 0. We have here 10 0. It represents with the 0 voltage, and the last one is 1 1 1, 10 1. Here it is 5 voltage. How many line exactly I have here? The question answer 2 to 10, and it equals to 1024. It means I got here 1024 addresses to represent my voltage between 0 and 5 volt. In this case, the 0 is in the decimal system is 0. 5 volt in the decimal is 1024. Let's have a simple math. Imagine that I am reading a 2.2 volt from my analog input. What kind of digital value in the binary system I am going to have, or in decimal, which number I am going to have? It is simple math. Here we go. We all know that 5 voltage represent with 1024. In this case, 2.2 watt. This is x, and x equals 2.2 times 1024 divided by 5. When we have that calculation, and let's make it here, go to scientific calculation. What was it? 2.2 times 1024 divided by 5. Yeah, here we go. 450. We can ignore the after the flood. We can ignore the 56. Let's accept it as a 450. This means when we come here, 2.2 volt is going to represent with 450. It means when we have 2.2 voltage from analog input, we'll also have in the value 450. What about the binary system? Our calculator also can convert it into binary system here. 400 in the decimal, as you see in the binary, it is 0100000111. It is 9 digit. Normal has to be 10 because there is 0 here. After the 1 we do not ignore the 0, that's why it does not show 0 here. But in the binary system we'll have here that. This is how we work with analog input. Come back here on diagram, guys. We read here the value, and we have got the op-amp. How op-amp works here: compare two inputs, positive and negative pins. If the positive value the value in the positive pins is bigger than the value in the negative pin, makes the output 5 voltage. And if it is 5 voltage, as long as you start your program, it start counting from 0, 1, 2, 3 till my own output gets bigger than my reference value, and then it's going to be 0, and I'll have my own digital value from outside, because we have got here digital analog converter. At the same time, when you are counting up, it also convert that digital to analog signal. In the 5th step I have got 78 millivolts. This means it is bigger than 60. It means my digital number here 00100, it goes like that. It means 60 millivolts represent with that specific number, but this is digital. You can also convert it into decimal. In the brief, how analog input, guys, works. And now let's have the simple project to understand the idea of analog in Arduino. I've got Proteus and I already drew my own project here. We'll use here the LED. We are going to run LED, and it is connected to pin 7. It is digital. It is going to be digital because there is no analog output, as I told you. And here my own analog input. It is connected to A0, and it's connected with the pod. First pin is connected to the 5 voltage, the third one to ground, and the middle of it is my own data pin is connected my A0. When I move to here the value of resistor, the voltage between the second pin and third pin is going to increase or decrease, depends on what is your own resistor here. And then according to my value, I'm going to read it from analog input, and then I will make my LED on. And when my value here in analog signal is increasing, the duration of LED is going to be increase either parallel. This means when I have a 5 voltage, the durations of LED is on, it's going to be longer than the 0 voltage or 2 voltage. But how I'm going to do that? Let's jump into our own software program here and open the new one. Copy this one and come here, because I already saved this one. I already uploaded it to my own microcontroller. I do not want to do it one more time. That's why I got it here. Okay, first of all, I'm going to define the value. The data type is going to be integer. Int value equals to 0. It will start with 0. Okay. And now I'm going to make my adjustment. First of all, you guys see here, I'm going to use pin 7 as an output. This means pin mode. Pin mode is going to be, here we go, out. This means 7, output. Yeah, that's it. Finish the line with this semicolon. Go back. Get another one, because we have got also input 1. to read our own value from pod. This is going to be input, but this one is going to be analog 0. Okay, now my Arduino is going to know the pin 7 is output and A0 is input, analog 0 is input. Now I'll start with to read my own data from pod into the value. I'll hold my pod value, my voltage in the analog pin in the value. How I'm going to do that? Value equals to, now I'm going to read the value from analog pin. That's why we already talked about the digital read and write. It's the same, but it's just going to be analog. Analog. I'm going to read it. Okay. I'm going to read it. Analog read. Here we go. What I'm going to read? I'm going to read analog 0. This means analog 0 is going to be read it, is going to be read and assigned into value. This line is done. So here we go. I read my value from here, the voltage that I have in the analog pin, and then I will put that value in my value. And then how I'm going to do that? I'll have a for loop, guys. How we use for loop? For I've got two semicolons here. I'm going to divide my own value into three different sections. The first one is going to be my own value. It is going to be int. Let's say I'm going to use e equals to 0. It means the first one says my own beginning value. I'm going to count from 0 till e less than, until e less than or equal than my own value. Yeah, here we go. This is perfect. And what is going to my step? E plus plus. This means I will start from 0 and go up one by one, and when I reach my value is here, the voltage that I read from analog signal. Till that value I'm going to count, and during that period what I'm going to do, I'm going to make my own digital output hike. It means digital write. I'm going to write it down. Digital write 7 is going to be hike. Yeah, that's the point, guys. And here I will put the delay to understand time is passing or not. Time, yeah, that's the point. Close it. What does it mean exactly, our code here, guys? I want to talk to you a little bit more about it. I read my value, the voltage from the analog read, by the analog read, and I assigned it into value. Now my value is hold to my voltage in the decimal that I already told you here how we convert it. After that, I have used the value, the maximum limited point that my counter is going to count in the for loop. For loop has got three different sections. One of them is a step. It's going to be one by one. It's going to increase one by one. This beginning value and the maximum, and our own voltage is going to limit the for loop here. Let's say that I read 5 voltage as a scenario. It means my value is going to be 1024. It means from 0 to 1024 my 4 is going to count in it, and during that period my LED is going to be high. After that it will go out, and I'll do this exactly the same process to make my own LED low. Yeah, if I read the lower value like a 1 voltage, it means the durations is just cycling here in the for loop is going to be decreased either. For now it looks like okay. Let's verify it and see if it is working or not. Okay, we've got a problem here. Okay, what kind of problem we have? Let's check it. Oh, we put 2 semicolon. Okay, do it one more time. Then another problem is the same one. That's why exactly it's not going to work. Yeah, that's right. I compiled my program. Now we'll simulate it in the Proteus. Let's see on the Proteus. Let's see it's work or not. As you see, the duration, guys, is a little bit longer right now. So let me move the resistor down here. Yeah, it is off. Probably the delay is a little bit long. That's why I'm going to delay it, and I'll make it 1. Okay, because it keeps the program waiting, and that's why we have to wait longer. But if we make it 1, I'll decrease that time. Okay, let's run the simulation one more time. Here we go. You see the blinking time, and we have got here 1.42 volt. When I have more voltage input, like a 73 voltage, the duration is going to be less. The blinking in the 1 second is going to decrease when my value is getting increase. Here we go. It goes like that, guys. I hope it is useful for you, but try to practice your own skills, and then you can be able to use the Arduino analog input. If you get any questions, don't forget to comment and I'll answer. Bye bye till next video.